Hey, this is it. Monday, May 11th. This is the beginning of our fourth and final unit of the year. And this unit is all about energy. So we're going to be talking about kinetic energy and potential energy. So when's the last time you went bowling? Well, when you go bowling, what you're doing is you're trying to roll a ball from one side of the bowling alley to the other side and trying to transfer that energy to knock down those pins. Have you tried ever using a lighter ball or a heavier ball and seeing the difference? What about a bullet? How come bullets are so powerful and dangerous? Well, it's all about the amount of energy that is applied to the bullet. Even though the bullet's so small, because it's so fast, it has a lot of energy. And then with a bow and arrow, you're creating a lot of energy by pulling back the bow string, and then when you let go, that bowstring energy then gets transferred to the arrows. So all of these are examples of energy. You're going to have a My Way, it's page 86. So please talk about kinetic energy and potential energy and give me examples of each. So on page 87, let's talk about the benchmark. So this is conservation of energy. You can never create or destroy energy. Energy is converted from one to another. So the total energy never changes. And in this GIF right here, this is a very classic demonstration of this. When he's holding that bowling ball at a certain height and lets go, the bowling ball can never have more energy than it started. So what happens is the bowling ball can never go higher than it started. So because of the laws of physics, he can trust and he has confidence that the bowling ball will never gain energy and thus never go higher than he lets it go. Now, will it lose energy? Through friction and stuff like that, but then the energy is converted to friction energy. It's never really lost, it's just converted to another one. Have you been to a carnival and tried to play this game? This game is super hard because what you have to do is you have to give it enough energy to go over this height, this loop right here. But if you give it too much energy, then it's going to keep that energy and then come back over again. So you have to give it just enough to get over and not enough to come back over. So that's why it's very tricky to do those types of activities. Let me show you a quick video about the conservation of energy and how energy can never be created or destroyed. So as you saw in that video, the energy is always preserved. So the solar energy gets converted to electrical energy, which gets converted to mechanical energy. So if you just add up all the energy in a system, it should never be increased or decreased. Now, in this case, the professor did a good job. He stood still. He made sure that he didn't add any energy to the bowling ball, so therefore the bowling ball can never go higher. In this GIF that I'm going to show you, the teacher was pretty successful at showing the conservation of energy. She just made a mistake of not telling the student to keep seated. So let's see what happens here. So she lets go, it comes back, oh, barely, and everybody's safe except for the fact he stands up and, ooh, bad timing. He's all happy and then, oof, okay. All right, so for your textbooks, speaking of textbooks, please return your orange textbooks. Otherwise, I would have to send a bill home for $65. There is a CK12 reading, 3.3, Energy and Roller Coasters. Roller coasters are fantastic. demonstrations of kinetic energy and potential energy. So take your notes on page 88, 89. And lastly, there's that phenomenon. Um, this is quite interesting to think about why different objects either hurt you or don't. If you got hit by a softball, probably hurts a lot. Why? Because it has more mass than maybe a ping pong ball. However, a gun shoots a bullet. A bullet has very little mass, but the bullet can travel very fast. So we're going to do an activity later on about comparing how the mass affects it, how the velocity affects it, and stuff like that. All right, see you tomorrow.